Hello students, today we are going to discuss torque and angular momentum of system of particles. As we know, if a particle is rotating with respect to a fixed axis, then its moment of force means the torque is given by its position vector with respect to origin vector product with force on that particle. So torque is the rotational analog of the force. Similarly, for that particle, the angular momentum of the particle is given by its position vector multiplied with its linear momentum. Now, if a system is composed of too many particles and each of the particle having its individual torque and angular momentum, then in the combined form we have to derive the expression for the torque of the system of particles and the angular momentum of that system of particles. So, for a system having n number of particles, angular momentum of system L equals to vector addition of angular momentum of all the particles of the system L1 plus L2 plus up to the nth term, which can be further expressed as the angular momentum of the system is sigma I equals to 1 to n Li. Now let us denote the angular momentum in terms of linear momentum. Then we can express the above equation as L equals to sigma I equals to 1 up to n Ri and its vector product with Pi. The position vector of the each particle multiplied by the linear momentum of that particle and the vector sum of angular momentum of all particles. Now differentiating the equation with respect to time, we get d by dt I equals to 1 to up to n Ri cross Pi, which can be further simplified as sigma I equals to 1 up to n Ri multiply d by dt of Pi. So finally we can write the equation, the torque of the system is equals to the sigma I equals to 1 to up to n Ri cross Fi, which we can further rewrite torque of the system of n particles is equals to sigma I equals to 1 up to n term torque I, means it is the vector sum of torque of individual particle of which the system is composed. It means when a system is composed of n number of particles and it is rotating with respect to a fixed axis, the torque of the complete system is considered as vector sum of individual torques of the particles of that system. Now the torque, it can be considered as internal or external, but since the internal forces in a system are balanced, so we generally not take it into account and consider only the external torque or the force provided to the system. So only the external force is to be taken in the account. It means the external torque provided to the system is to be taken in the account. So finally we can say that for the system of n number of particles, the net torque is equals to time rate of change of net angular momentum of the system with respect to a fixed axis. Now we will discuss conservation of angular momentum of that system of particles. As we know from the Newton's second law of motion, if there is no external force provided to a system, in that case, in the absence of external force, the system will retain its original position in which it is at present. Suppose if the system is at rest, it will continue at rest until an external force is applied to it. Similarly, if a system is in motion, with a uniform velocity or uniform angular motion. In that case, if external force or torque is not there, it will continue its motion with the same. So this concept generates the term conservation of angular momentum for a system of particles. So now we are going to discuss the conservation of angular momentum. In the absence of external torque, means torque external is equals to 0. The term dl by dt is equals to 0, or we can say L is constant. It means no change in the angular momentum of the system when there is absence of external torque. We can also consider the same statement in such situation when there are different torques producing the rotation of the body in different planes. In that case, if we take the vector sum of all the torques and the vector sum of all the torque is 0, it means the vector value, it means the vector representation of the angular momentum will express itself as a constant for the complete system. Means the angular momentum corresponding to x-axis, angular momentum corresponding to y and z-axis will all have their combined impact such that on that body that the net vector addition of the all angular momentum will be constant. So that's all for today. We will discuss some example or numerical problems based upon these terms. Till then, good day.